All right, so this is going to be a lecture that's going to basically continue where we last left off with covalent bonds and dry and Lewis structures. You can consider this LE covalent bonds, but we're actually going to add a part to it. It's going to be LE covalent multiple bonds. The emphasis on the multiple part. So we're going to be drawing Lewis structures where there are more than just single bonds. So we're going to start off with a molecule which is CS2. We're going to follow the same rules that we always have, and that's to count the total number of valence electrons. You want to follow the same rules that I gave you when it came to drawing structures with single bonds. So carbon has 4 valence electrons. Sulfur has 6 valence electrons, but I have 2 of them, so that means I have a total of 12 valence electrons. I add these 2 together, and of course I have 16 valence electrons. Now what I'm going to do is follow the same protocol you followed before, which is start with your central atom. Usually the first element symbol is going to be your center atom. It's usually the one with the most unpaired electrons. Carbon's typically a central atom. So I'm going to put carbon in the middle. Then I'm just going to stick sulfur opposite each other. I'm going to put them opposite like that. And then I count the number of valence electrons that I had to use to form the connections of all the outside atoms. So I used this stick and this stick. Each stick, remember, is 2 shared valence electrons. So that's a total of 4 that I've used up now. 2 here and 2 there. That's what that stick represents. So I'm going to subtract 4 valence electrons from the total I know I have to use. So that means I still have to fill in 12 valence electrons in the structure. Start by adding them to the outside atoms first and then to the center. So if you fill up all the outside octets first, then you never get to the center. So let's start adding in 12. So I've got 2 here, 4, 6, 8, 10, 12. Okay, so I actually used up all of my remaining valence electrons from my original total. So I don't have any other valence electrons to work with. And remember, I need to have an octet because everyone has to look like a noble gas, or at least they have to have a noble gas electron configuration. So when I look at sulfur on the left side, I've got 2, 4, 6, 8. Oops, didn't mean to make a dot there. And then I have carbon. I only have 2, 4. So carbon is actually short valence electrons. So what I can do is I can take 2 of the electrons that are non-bonding around one of the sulfurs, and I can slide them in as a bond between the sulfur and the carbon. Let me redraw this molecule after having done that. So I've got my sulfur, and now I have 2 lines between the carbon and the sulfur. Let me finish drawing this out. So those 2 electrons went there as a double bond. So now, sulfur actually still has 8 valence electrons around it. It has 2, 4, 6, 8. Carbon, however, now has 6. So it still needs 8, so let's bump in another 2. So these 2, this time I'm going to make come in from here. And I'm going to redraw my structure. And we can see now that the structure that works is one where there's a double bond between the sulfur and the carbon on the left side and a double bond between the carbon and the sulfur on the right side. Everyone has an octet. Everyone's happy. This is the most appropriate Lewis structure for this molecule. Now we're going to do a different problem. We're going to do CH2O. CH2O, we're going to follow the same process we did before. Carbon has 4 valence electrons. Each hydrogen has 1. I have 2 hydrogens, so that's a total of 2 valence electrons. And oxygen has 6 valence electrons. So I'm going to add all of those together. 2, 6 plus 6 is 12 valence electrons. My central atom is probably going to be carbon. Makes the most sense because it's the most unpaired valence electrons. And it is first in my symbol. I mean, my formula here. So I'm going to draw a carbon, hydrogen here, hydrogen there. Why not an oxygen there? So let's see how many electrons I've used so far. 2, 4, 6. Let me take that away from the total. So now I have 6 valence electrons that I need to spread around the outside. I'm not going to spread them around the hydrogen because the hydrogens are already complete. Remember, they only need 2 valence electrons. They only form 1 bond. Those 2 are done. So I'm going to go over to the oxygen. Remember, I fill in my extra valence electrons, these 6, on the outside atoms first until I've formed all of my octets on the outside. So here we go. 2, 4, 6. All right, I'm done. I've used up all of my valence electrons. But I don't have an octet for everyone. My hydrogens are fine, and my oxygen's fine. My oxygen has 2, 4, 6, 8 around it, but the carbon only has 2, 4, 6 around it. Remember, those lines represent 2 dots. All right, so let's move one of these pairs on oxygen in. I'm moving it in, so now my structure looks like this. So now my carbon actually has an octet, 2, 4, 6, 8. And my oxygen still has an octet, just like it did before, 2, 4, 6, 8. This is the appropriate structure. Now, you could have started off, let's re-examine another possibility of what we could have done. We could have also started this top one down here, and we could have done it this way. We could have drawn it like this. A carbon, hydrogen here, an oxygen up there, and a hydrogen over here. Then, all we have to do is we would do the same steps we did before. We'd fill in our extra electrons there, and then we'd bump them into the carbon, and we'd move to this final structure, which would be looking like this. And I just want to let you guys know that this, what I've drawn on the bottom, these two are equally correct. There is nothing wrong with either of them. Now, let's jump to a harder question. Let's jump to questions where we actually have to start thinking about charge. Remember those polyatomic ions we learned? And I said, we're not going to worry about the structures for those guys because they're covalent. Well, now that we know covalent stuff, we're actually going to have to write the structures for polyatomic ions. One of the polyatomic ions that you learned about was carbonate, which has a -2 charge. Let's do the same steps we did before for drawing out its structure. This time we have a charge which changes things slightly, though. The carbon has 4 valence electrons. Each oxygen has 6, so that's a total of 18 valence electrons that I need for that guy. Let me draw little arrows indicating what I'm doing here. And then I have something else. See this -2 charge? The -2 charge means I have 2 more electrons total, because it's -2. So I'm going to add another 2 valence electrons, so my total is actually going to be 24 valence electrons. Now I'm going to follow the same steps I did for the previous molecules. I'm going to make the first one the central atom, or the one with the most unpaired valence electrons. So I'm going to put carbon in the middle. Then I'm going to branch off my 3 oxygens. Okay? Now let's see how many valence electrons I've used so far. 2, 4, 6. So let me take 6 away from what I had in the beginning, which my total is going to be 24. So I need to fill in 18 dots, 18 valence electrons. Remember, I start by adding them on the outside first. So let me go through it. 2, 4, 6, 8, 10, 12, 14, 16, 18. Wonderful. Now I check for octets. This is an octet, 2, 4, 6, 8. This is an octet, 2, 4, 6, 8. This is an octet, 2, 4, 6, 8. But I've got a problem. Carbon's not an octet, 2, 4, 6. So let's bump 2 of these valence electrons. I could have picked any oxygen. It actually doesn't matter. And now I have a double bond between one of the oxygens and carbon. And now everyone has an octet. Now there's something we have to do. Remember in the beginning I said this is a polyatomic ion and it has this -2 charge right there? Well, we still have to show that this whole thing, this whole polyatomic ion has a -2 charge. We put brackets around it, then we put a 2- showing all of that has a -2 charge because we added 2 more electrons to it. All right, that's the gist of it. I'm going to assign you a total of 6 more additional problems besides the worksheet. 6 more problems. And I just want you to draw the Lewis structures like this for these problems that I'm about to give you. I would like you to do SO2. I would like you to do C2H2. I would also like you to do, actually it's only going to be, sorry, I'm going to make you do 5. 5 more additional problems. SO2, C2H2. I'm going to have you do NO positive. I'm going to have you do NO3 minus. And then I'm going to have you do O3. The one that's going to be the most challenging for you perhaps will be this one. So I will consider this one your advanced question. You get all of them right, you have an advanced. That looks good for getting an A. If you guys have any other additional questions, please don't hesitate to come in for tutoring. I'm available Tuesday and Wednesday after school. Thank you.